So we've already established that fermions can't be in the same state as each other. You can put one fermion into a particular state, but then you can't put another fermion in because they can't exist like that. Which means also there must be some dynamic process that stops the second fermion from coming in. Something simply built on the basis of the antisymmetry of the state. Similarly, for bosons, we know that we can put more than one particle in the state. And in fact, it turns out that it's more likely that if you try and make a transition of taking a boson and putting it into a state which already has one of those bosons in it, then it turns out that transition is more likely. Now, to understand that, we can build that with a very simple model. All we need is the simplest possible model we can get of trying to turn one thing and put it into a state with and without the presence of another particle in that state. Let's consider two particles, 1 and 2, that are undergoing a change from state A to state B. Now we can make a sort of Feynman-like diagram of this process. So we'll have a particle coming in state A and going out in state B. And we're going to have the other particle coming in something completely different. Or we might have that transition happen where we already have that second particle in state B. Okay, so in this case over on the left, what we have is two particles, one in state A and one in state C, turning into two particles, one in state B and one in state C. So in a sense, this C is coming along for a ride. On the right over here, what we have is two particles, one in state A and one in state B, and one of them is being turned into B such that we have two particles in state B. Okay, now let's try and write down the simplest possible Hamiltonian that can do this. So grab a piece of paper and have a go writing this down yourself. Try and write down the Hamiltonian in terms of the kets and bras of the first and the second particle, such that you're converting the particles from A to B. Remember all the properties that the Hamiltonian has to have and make sure your Hamiltonian satisfies all of them. When you've had a good go, come back and check the next video.